Well, hello everyone. This is Audrey Codner. I am actually a online math tutor. A lot of you guys probably have seen my stuff, or you probably see me selling my products. Well, one, I want to say Happy New Year to everyone. And I know everyone usually has that slogan of New Year, New Me. So one of the things that I know a lot of people are either thinking about at this time as they're recovering from their lovely hangovers is, hey, how are you? Thanks for stopping on in. So a lot of you guys are probably either thinking about, you know what, I need to go back to school. I'm trying to get my GED, or I'm going after trying to do the ASVAT. So I want to get into the military. Or maybe you're just trying to go to a community college and go for the AccuPlacer. And you're probably like, you know what? I haven't seen algebra since I was a fetus. So instead of like trying to say, you know what? This is not about me. I should stop. I'm going to actually help you guys out with a couple of concepts, as well as, or in addition to some of these concepts that a lot of people generally get wrong on the GEDs or any of those assessments, is I'm going to help you break down some of these concepts, keeping it light, keeping it easy in order for you to excel. So one, thank you guys for coming on in. And if you have questions, please do not hesitate, because I do have a couple other things. For some reason, a lot of things are all kinds of Cookaboo Johnson right now. But what I want to focus on today is going to be rate of change, aka slope. This is something that everyone tends to get wrong. It doesn't matter what age you're into. So if you think of slope, think of it, and especially if you're international, think of it as gradients. So if you're a truck driver especially, and when you're driving the truck, you usually see a sign with a truck going up the hill, and it gives you a percentage. That's the gradient on how high or how steep is that hill. Okay, the bigger the percentage, the higher the steepness. Then you might see some trucks when it's going downwards. That means you have a gradient that is going into what we like to say the negative direction. So the lower and how less steep it is. Then we also have the horizontal line, which goes straight up and down. I can use my pencil. So this is more horizontal. That is the zero slope. You're just driving on a regular road. And then you don't want to ever see a slope that's going to go up and down because that's no slope, okay? That means you just dropped off the side of the mountain, and we don't want that at all. So what we're going to do is we're going to look at those 4 different types of slopes, and I'm going to use this math notebook that I actually designed to kind of help everything goes along. So normally you have like a topic of it. We're going to look at rise over run. And before we even get started, tell me in the chat roughly how you're feeling. Okay, some people are coming in and coming out, but then are you doing great? Or are you meh? Or are you just like, you know what? Why are you putting math in front of me? Okay, so you can definitely put that into the chat and tell me how exactly you are feeling. Now, the one thing I like about my notebook, not just because I designed it, is because I have the formulas. Okay, so a lot of people are just like, okay, there is a trend, because if you're going to go positive, and I'm just going to draw like a rough graph. If I'm going positive, That means as my x values, which usually goes left to right, as those are increasing, my y values, which goes up and down, they're also increasing. Okay? So when it's both x and the y are both going up, that means you have a positive slope. So when you have, I'll slide this over. Again, my y values goes up and down, my x values left and right. So this time, if I drew a line this way, as my x values increase, my y values, they're decreasing. So when I have a difference of signs, that means I have a negative slope. Okay, so it's always dealing with the steepness. Then the next one, if we have our y values and our x values, and it goes straight across, like you're driving on straight land, okay? I drove through Kansas once. Yeah, very flat, but awesome people. But if it's straight and it's flat, this is what's called a zero slope. Okay, so you do have a slope, but it's a zero slope. Okay, the ones that usually give you trouble are the ones that goes right through just the x-axis. Okay, this is an undefined slope. Okay, undefined. Anytime it goes straight up and down, it's going to be undefined. Left and right is going to become zero. If you read it from the left to the right and it's angling down, that is a negative slope. And if you read from left to right and it's going up, it's a positive slope. So sometimes most of those exams are going to be multiple choice. So if they give you a graph and you look at roughly where the slopes will be located, which I'm going to show you, you can basically do a process of elimination. So with that in mind, we're going to actually take a look at a couple of what's called rate of change, aka slope. So there's going to be times there might give you a table. So I'm going to old school it up because I can't find my ruler. So I'm going to use my pencil to pencil. This is how we used to do it back in the day. So my x values are always going to be on the left. My y values will be on the right. So right now, we're not really using my formulas because we're looking at it as a table. And I'm going to show you how to do that rather quickly. So if we said my x values, we have 0, we have 2, we have 4, 6, and 8. And for the y's, we have -8, -5, -2, 1, and 4. So in order for me to tell what type of slope is this, we're looking at this section right here. Slope is just basically the change of y's over the change of x. That's what the triangle means. So if you ever see someone using a triangle, thanks so much for the love. If you see the triangle, that means delta. And if you know any more sororities where they talk about delta 5, delta this, delta means change. So all we're taking is looking at the pattern of our y's over the pattern of our x's. Since our y's are always up and down, remember, here's my y-axis here, y-axis, it always goes up and down. So that's my rise. When you bake a cake, hopefully you put enough ingredients in it so it can rise. Now, your run is your left to right. So left to right is your run. That's your x-axis. So when you run across the street, you're usually going to go straight like this. You're not going to be like, all kinds of crazy. You're just going to run straight across, okay? So sometimes I like to say you got to rise out of bed in order for you to run to the bathroom. You know, when you get older, these things happen. But when you look at it as a table, now we're really taking a look at the pattern. So what's going on? Let's take the x's. What's going on from 0 to 2? What's the pattern? So hopefully you're saying you're going up 2. You're adding 2. 2 to 4, we're adding 2. 4 to 6, we're adding 2. And the same with 6 to 8. Woo, I said 8 and I'm about to write 8. This is why we have erasers. And that's why erasable pens work awesome for this book. Now, taking a look at the y's, I know for a fact that you're probably saying, what are negatives, Audrey? What is this? Well, if you don't really quite understand what the negatives are, remember, when you take these exams, they are only looking at the correct answer. So I'm going to kind of drop down to 1 and 4. What's the pattern to 1 and 4? We know that. You're actually adding 3. So if I take negative 8, so think of it this way. Let's see if this positive 3 will also work for this. I am in need of $8. Someone gives me 3. How much money am I in need of now? I'm in need of $5. Okay, so let's see if the pattern works with the negative 5 and the negative 2. I'm in need of $5. Someone pays me $3. Now I'm in need of $2. So it seems like the pattern is kind of working. If I go from negative 2 to 1, so let's see. I was in need of $2. Someone paid me $3. That means I'm ahead. I got an extra $1. So this is working for all the patterns. So I'm looking at the pattern of my y's over the pattern of my x's. So the pattern of my y's was 3. The pattern of my x's is 2. So we just found our rate of change. And here's another thing. I don't know why there are y's over here. You could tell I was doing this at 3 o'clock in the morning. Yeah. These are supposed to be m's. Again, gotta love an eraser. Okay, m represents slope. Okay, if you ever look at any of equations, you will always see the letter m and it always represents slope. So my rate of change, aka slope, for this example with the table is going to be 3/2. That means if I were to graph it, I would rise up 3, wherever my starting point is, which we're going to talk about starting point next time. But wherever I start from, I would go up 3 and to the right 2 to draw my second point. That's basically what we're doing. So a lot of people, when it comes to the slope, since I was positive 3 here and positive 2 there, that means I'm going to have a positive slope, just like that first example. So say if I were to start here at 0, I'm just going to use my pen. I'm going to start here at 0, and I would have to go up 3, 1, 2, 3, because that's my rise, and over 2, 1, 2. That's my run. And I would continue that, 1, 2, 3, over 1, 2. And then guess what? That blue line gives me my positive slope. Okay? So I can have the formulas as a reminder here that I'm looking at the change of y's over the change of x, but then I can go deeper into this if I want to. If they want me to calculate my slope, I can do this one of two ways. We have the formula which says y sub 2 minus y sub 1, x sub 2 minus x sub 1, and you're probably like, say, what, Audrey? So this is what's happening. So let me kind of shift us a little bit. So if I gave you 2 points, let's just say I give you 2 and negative 1. And I also give you 6 and 9. Why not? Okay. So they give us 2 coordinates of a point that's supposed to go in this grid. So if I may, I'm going to use my handy dandy. Let's see if I can make this somewhat legit. Let's go to here. So I'm going to go in between. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that'll be 1, 2, 3, 4, 5. Notice I used the dots. 1, 2, 3, 4, 5 right here. I use the dots to kind of help me use my graph so it can be somewhat consistent. So if I were, and then we got some negative numbers here as well. And I like to make my 5s a little bit bigger. All right, so if I plot the point 2, negative 1, I will start here at the origin. You always start at the origin when you're about to plot a point. The 2, that's going to be my x values. So that means I'm either going to go left or right. And the negative 1, that's telling me I'm either going up or down. That's my y. So if I start here at the origin, I have a positive 2, so that means I'm going to the right 2. And then I have a negative 1 for the y, so I'm going down 1. And I plot that point. So this is 2, negative 1. Let's see if I can make it a little bit bigger. Definitely not. All right, so let's see if I can zoom in a little bit. If this is not too intense, probably. Okay, so taking a look at it, when we have 6 and 9, so we go starting here at the origin, we go to the right 6, and then we're going to go up 9, and we're going to plot our point. And that point's like roughly about here. So this point is 6, 9. So by looking at it, if I were to draw a line, it looks like I'm going to get a positive slope. So with you having that positivity, when you look at the answer choices, right away you can say, all right, I can eliminate anything that's going to give me a negative slope or a 0 slope. Boom, done. But we can also calculate what exactly is this slope. So if we take a look, this 2, negative 1, this is the first point I see. So I'm going to make that my x1 and my y1. Because since I know how to read from left to right, that's going to be my first point. This will be my second point. So this will be my x2 and my y sub 2. So a lot of people generally say, oh, so that's where the 1s and the 2s are coming from in our formula. So what happens is a lot of people know with this formula. Whoops. So a lot of people know it by this, the y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But a lot of kids usually get it screwed up, especially when it comes to the positive and negative signs. So I like to go from left to right, which will give us our y1 minus y2 over our x1 minus x2. Notice the 2's and the 1's are always in the same levels. Okay? So as long as those are lined up, you can use it either way. It really doesn't matter. So what I want to do is I want to take these numbers. Let's see if I can get my highlighter out here. Okay, I want to take these coordinates, and these are going to be the x and the y's to kind of support that. So now I'm going to use the formula. I use my m is equal to the change of y over the change of x. So let's take the difference of our y's. We have a -1 minus 9. Then we have our x's. So since we started in the first parenthesis, we start with the x's in the first parenthesis. So it gives me 2 minus 6. So now all we have to do is do -1 minus 9. So let's take a look. I'm in the hole $1. For some reason, a charge went on my account. And now you're in the hole. That charge was $9. So that means you're in the hole $10. Negatives, if you think of it as money, it's either money that you owe somebody or it's money that you're losing. So that's why I like to think about the negatives. So thanks, guys, for coming in. I appreciate it. So now we have 2 minus 6. So 2 minus 6, that means I have $2 and I'm trying to spend $6. So that means I'm overspending. That means I'm short. And I'm short $4. So my slope is -10 over -4. But then this is when early on people talked about signs. When you're doing multiplying and dividing and your signs are the same, your answer is always going to be positive. So we actually have a slope that's going to give me a positive 10 over 4. But 10/4, they're both even. So especially those that are going to be working with ASVAT and GED, they always have fractions on there. And the way that you reduce a fraction, you want to take a look. If they're both even, that means they could be divided by an even number. What's the first even number that pops in your head? Exactly, 2. So why not try to divide both that numerator and divide the denominator, which is the bottom one, by that 2. So when you do that, 10 divided by 2, that gives me 5. And half of 4, because that's what you're doing when you're dividing, 4 divided by 2, that gives me 2. So my slope is 5 halves. And it's positive. So let's see if that matches up with what I got here in my graph. Let me raise this up just a hair. We'll figure it out one day soon. Oops. Or maybe not that much. There we go. All right. So if I'm starting from one point to the next point, they're saying my y's, which goes up and down, I have to go up basically 5. So let's see. If I go up 5, that'll be 1, 2, 3, 4, 5. And now I have to go over 2. 1, 2. And you're probably saying, well, Audrey, we didn't reach the other point. I know we didn't. So let's see if we can do it again. Let's see if it will get us to that point. So we got 1, 2, 3, 4, 5, and over 2. 1, 2. Hey, got us right on that point. And if you take a look, draw my pencil, old school it up. See, guys, we don't need rulers. Did you know the original pencils, when they had it like this, that was the reason why, so we can draw lines. Huh, fun fact. Anywho, now you notice we got that positive slope. Even though, or although, we went up 5 and went over 2, we didn't get on top of the second point that was here. But if I did it again, that same pattern, I eventually will get on top of that second point. So we have that positive slope. So what we did today is we looked at it as a table by finding the pattern of our y's and putting it over the pattern of our x's. Other thing that we did, we calculated using 2 points, using their coordinates. So once we took a look at the coordinates, again, we just basically take the difference of our y's and then put it over the difference of our x's. And you're probably asking, well, why do they originally have us do the y2 minus the y1? Well, you got to stop and think. Most, if you haven't noticed, a lot of our math is usually oriented from the Orient. And they read from the right to the left. So it makes sense to them. But us in the States, it makes sense to a lot of our kids because we read from the left to the right. And you will get the same exact answer. All right. If you don't believe me, let me switch it up. So let me see if I can put it down here. I think you can see it. So if I go for my slope, if I changed it up and I went backwards and I said 9 minus -1 over 6 minus 2, when you minus a negative, that's the same as saying a negative times a negative. So negative times a negative, it turns positive. So that's 9 plus 1. So now it's 9 plus 1. That gives me 10, not to insult your intelligence. And then 6 minus 2, that gives me 4. Huh, this looks familiar. Isn't that the same thing that we got right here? And then we reduced that 10/4 by dividing by 2. And the reason why we did that is because both 10 and 4 are even. And as a lovely result, it gives us 5/2, which is exactly the same that we got up there. All right, so the reason why, and this is just a sample. So what we could do in the steps section is we can either write out the steps on how to solve it algebraically, which means labeling. So we can just do 1. We label our x1, y1, x2, y2. Okay. Then the second part, we're going to use the equation. And this is where you are going to fill in which equation you're going to use. Are you going to use the top one where it says y2 minus y1? Or are you going to use the bottom one that says y1 minus y2? That's going to be up to you. So I'm going to write it out. M equals y1 minus y2 over x1 minus x2. Third step, I can do remember a negative divided by a negative equals positive. Okay, so that might be like the next part. Let me see if I can angle this a little bit. Okay, so now you got that part. And then part 4 will be reduce reduce your ratio. And the ratio is your fraction. Okay? So the reason why I designed it like this, it kind of helps me a little bit with Cornell notes. But the reason why is I want people to quickly be able to identify what the formulas they're going to use and also to identify the steps. And especially like if you have a teacher that likes to do open notes quizzes, this will give you right to it. Okay. Now, if you are a teacher and you're just like, oh, I kind of like this, and especially this part up top, you can actually do the lesson, the I do, you do, we do type thing. And then afterwards, when they're doing their individual, you can ask the kids, hey, I want you to quickly tell me how you feeling about this lesson. How you doing? And have the kids circle exactly how they feel. And maybe even homeschool parents, like the ones that you're leaving your kids alone, but at the same time, you can actually grab their notebooks to see, are they doing their lessons? How are they really feeling about the lessons? And then you'll be able to get some feedback, or you might be able to get someone that can help you with it, almost like a tutor. All right. And then on the other side, so that's just one side. On the other side, if you want to do some extra practice, you can do some practice with the tables over here. You can do some practice with graphing. You can actually have the students fill in numbers in each of the blocks so they can keep track of their numbers. Because trust me, like if they wanted to do 10, I think it was like 10 minus 1 or something like that. And they can put the numbers like in between so they can keep track. I know I'm just throwing some numbers up there, but I can put a digit in each of the boxes so they can keep everything nice and neat and organized. So they'll be able to get everything done. And then this will be a -9 for my slope, which is M. So this is just like another way for people to kind of like keep track of your math notes. Like take a look at your kids' notebooks and ask them to see their notes. Trust and believe you're going to find stuff and you're going to be like, oh dear God. How can you read this? And like, I just write down what the teacher wrote down. And trust me, the teacher did not write it down like that. All right. So I have like basically 50 pages of the graph and then 50 pages of the notes. And one of the things I like to do with my notebooks, just to make it a little more easy, is to have these reusable tabs on the side. So you can get to them even quicker. Like, yes, I do have my pages numbered, but for the most part, I'm trying to show it to you as you guys are all going blind. Here we go. So I know you're trying to look at the pages are numbered, and I know in the beginning of my book, I generally have like a table of contents so the kids can actually write down what is the topics and roughly what page is it. If you have a super organized kid, that will help them. But if you have some kids that are like, I'm organized, but this is a bit much, then you can get the tabs. And I know I've used this book for a couple other examples, like for arc length, if anyone's doing geometry, if they're looking at the unit circle. And also I have some examples of like how they're breaking down concepts in geometry. If they get like a regular piece of paper and they just want to work on their notes and actually give a small example of how to solve, they can do that. So it's not just for like, say, algebra, but I designed this for my 7th through adults because most notebooks are not really focused on our advanced students. And then especially giving them as a place for them to write down their steps and a place for them to put the formulas so they can see it right away. Now, if you have some students that struggles with multiplication, which they all do, okay? They don't do the cadence like they used to years ago. I have designed a factor sheet, a factor chart. So if you notice, I have most factor charts that you'll see nowadays just goes up from 1 to 100. Okay, I went a step further. I went from 1 to 200. Okay, so I give you your prime numbers. The numbers that are prime, they're in yellow. Okay, the numbers that are of your perfect squares, of your perfect square roots, they're in blue. And if you ever have to break down a radical, let's say you need to break down the square root of 48. So let's say 54. We'll say 54 since it's up here. So I go to where 54 is. I'm going to see where it is right here. And then I notice that I'm going to go over and I see the factors of 54. So I got 1 and 54, 2 and 27, 3 and 18, and 6 and 9. So if I wanted to break down the square root of 54, I'm looking for what's called a perfect prime combination. A lot of the kids will say, oh, I can do 3 and 18. Yeah, that's true. But then you got to break down to 18. And now you got to deal with multiple prime numbers to really break it all the way down. So why not go for the 6 and the 9? Because 9 is a perfect and 6 is one of those special prime radicals. And then they can get their answers so much quicker. And I use this a lot with my tutoring students and they love it. They're like, oh my gosh, this is so much, makes my life so much easier. And especially dealing with larger numbers, because we deal a lot with 3-digit numbers. So like, okay, 163, instead of you trying to divide by 3 and divide by 7 and all this other stuff, then you'll just know, boom, it's prime. 1, it's yellow. 2, it's highlight. Okay? So that's what I did with the factor charts. And other resources, okay, we're looking at the operations. What are those words that hits, especially word problems? Our kids struggle with word problems. Now you get the whole list. What are the most popular words that they use for addition, subtraction, multiplication, division, equals? You'll be shocked and surprised what they will write down for equals. And then inequalities. Knowing the difference between is more than and more than is vital, especially is less than as well. You'll always have kids that want to put a plus sign and a minus sign when in fact they should be dealing with inequalities. In addition to the properties, the rules of integers. I kind of walked through that a little bit. We had a couple examples of it. So I give you what the rule is, and then an example of what it looks like. Notice here, my green plus sign is a lot bigger than everything else. So that means the value is larger. So 13 is bigger than a -6. So you're basically going to do subtraction and you're going to give your answer the sign of your largest number, which is 13. Not the largest value, but the largest number. So with that, you have all of this. We have our linear and our quadratic equations that's already there. Hey, notice what's at the very top is the slope. I did refine the new book, the one that's already on Amazon, and they're all color pages. I was just waiting for Amazon to give me my copy. I'm working on week number 2 right now. Not happy, but I understand it's the holidays. Order of operations. What we know in the States is please excuse my dear Aunt Sally. But international, they might know it as, I forgot what they call it, bomb mess or something like that. They do the brackets. They do others of orders, which is your exponents, your division, multiplication, addition, subtraction. Very similar, except for the D and the M is switched up. Okay? Properties of exponents is also part of the listing. But then I start getting more advanced. Then we start looking at not only volume, we're looking at surface area. We're looking at total surface area. What are those formulas? Okay, we're looking at the area of the circle as well as sector and arc length. Then we get a little bit more tactfully done with the Pythagorean's theorem. We're looking at those right triangles. We're looking at sine, cosine, tangent, SOHCAHTOA. Then we're looking at the reciprocal identities. Now I'm talking about algebra 2 and pre-calculus. Okay, we're looking at those things. We're looking at the co-functions, which I'm going to actually add into the book because I totally forgot about those. Shame on me. And as well as the sine rule and the cosine rule, which is at the very bottom of the list. But then another game changer is your unit circle, okay? Making that unit circle all about you, how to figure out the unit circle, as well as giving you the small chance. So with those, that's the resources. Then you have your brain breaks, which a lot of kids generally like. Sometimes when you do math for a long time, you just need a moment. You just need a breather. So I put in some brain breaks where you can actually sit down, you can color, you can, if you're really into pixel art, you can actually do some drawing of pixel arts and also give you a space just to doodle, just to kind of get it out of your system. All right. So with all of those, they're all listed inside my math notebook. But I definitely want to let you guys know that you can organize it any which way you want. If you're interested in learning a little bit more, especially for the GED and the ASVAT, I'm coming out with some courses and I'm actually going to come out a little bit later. I just have to get myself ready for my next tutoring session. So I know it's a new year and everybody's like, I want in. But I will definitely put the link, or if anything, you can catch me a little bit later. I just all of a sudden didn't think I hit live, and next thing you know, I went live. So I guess that's how things go. But if you are interested, if you want, I have a QR code. I think you'll be able to capture it. So let me see if I can angle it a little bit. If you want, you can just like take a screenshot of that, and this will kind of tells you a little bit more about my math notebook. And I will definitely be coming on and doing a little bit more with slope today. And I think I might make this a normal thing if a lot of people are interested in it. So that's all I really have for right now, but I'm really glad that you guys were able to come in. Thank you for the people that showed me a little bit of love. I appreciate it. But remember, when you have this math notebook, it'll help your kids get organized. It'll help them get their thoughts situated. And it doesn't matter. Like here, I have dividing polynomials, okay, using the grid method. And you are able to use your examples here. Now, if your teacher also likes, it's always hard for me to end things, but if your teacher also says, look, I really want you to have this in your notes, and there's like a certain paper, you can tape it in on the grid side, and then teachers or parents, you can have your kids summarize what's on that paper over here on the note side. So now they have to learn by practicing. You can't just give kids stuff and they're just like, okay, yeah, yeah, I know it. Yeah, this is great. Yeah, I got it. Yeah, wonderful. Awesome. Yay, I'm done. No, they need to practice. Okay, that's the only way that they can learn and understand math is through practice. So if you are interested and want to learn more about it, I do have a link in my bio, which will also take you to my website. If you want, you can order this completely off Amazon. You just type in Audrey Codner. Or if you want to get a digital copy instead and print out your own pages, and you can print as many pages as you want, you'll get the whole entire book at a fraction of the cost. Because I know it's the end of the year, and trust me, no one has the money. Okay, we're all like, I want to be new, but not too expensive. Okay, so if you do have any questions, just go ahead and reach out. But I will be on later on this evening. I'm looking at roughly like around 6 o'clock, and I'm going to do exactly the same thing, but I'm going to go from slope to possibly slope intercept form. All right, so I will talk with you guys later, and have a wonderful rest of your afternoon. Happy New Year.